The first smart circular bridge was opened in April 22 in Almere, the Netherlands. It is a biocomposite bridge made out of flex fibers and bioresin. Here with me today is Maximillian Weil from the University of Brussels to talk about the results of the structural health monitoring. Hello, Maximilian.
Hi, Alexander, and thank you very much for this invitation. Today, I'll try and broadly explain what our structural health monitoring is doing, what it's monitoring, and then why it's monitoring.
Maximilian, what does the structural health monitoring look like?
So in our case, for this bridge, we had a very detailed structural health monitoring. This consists of 3 different parts. So first of all, we had an environmental monitoring the environment around the bridge. Secondly, we had vibration monitoring. So measuring the vibrations of the bridge, and especially how people walking over this bridge impact the vibrations. And thirdly, we also have strain measurements. So this measures the deformations on the bridge. And here we even embedded the sensors inside the bridge during the construction. So in total, we have 90 optical strain measurements inside the bridge.
Why do we need such an elaborate monitoring system?
This elaborate system exists because of different reasons. First of all, in this case, we're working with a novel material. So this biocomposite has never been used before in the construction industry. And when using this in Europe, you need a very good monitoring system to ensure the safety of your structure. Secondly, we're also trying to build trust in this material so that it would one day replace concrete in many different types of structures, so not only pedestrian bridges. Thirdly, we're also trying to look at how the bridge degrades, so how this material will age over time, and if it's still safe to operate, let's say in 20, 30, or even 50 years. And then finally, we're trying to confirm some laboratory results about this material. So we always make some tests before constructing in the lab, but we want to confirm this in a real case scenario.
With all these sensors, Maximilian, what exactly are you measuring?
So as stated before, we have 3 different types of measurements. So for the environment, we're measuring the wind speed and wind direction, the temperature and the air pressure. We measure this because it has an effect on the bridge and how it vibrates or deforms depending on different environments. Secondly, we're measuring the vibrations of the bridge at 3 different locations. And this enables us to capture what is known as the modal frequencies. So the frequency at which the bridge vibrates that needs to stay outside a given range for comfort and safety reasons. And then finally, we're also measuring the strain or the deformation. And so in this picture, we can then clearly distinguish the deformation that has been generated by 1, 2, or 3 people that are walking over this bridge.
Can we also take a look at the data, or is the data only available to you?
The data is of course not only available to me. First of all, it's available to all our partners through a private, very scientific dashboard. But we also made a second publicly available dashboard for everybody where you can see almost live, the data coming in from the bridge. So if you scan the following QR code, it will direct you to a link that will show you all the data that is gathered.
What is an interesting finding that you can share with us today that you have found in the last 8 months?
So we had many different findings. If I have to choose one, I would go for the event detection one. So we've detected all the events over the bridge. And when looking at this in the morning, we could see a very interesting cluster. There was namely vibrations that were generated by a vehicle rolling over the bridge. This couldn't be generated by a person walking over it. And it's no coincidence that just next to this bridge is a cafe where they need fresh beer in the morning. So this, filling of their beer kegs could actually be detected through our monitoring system.
And what are your personal conclusions after 8 months of monitoring the smart circular bridge in Almere?
So we had different conclusions, but one very interesting one is that our vibration levels stay well below the vibration levels that are required from the Euro norms. So even during our inauguration day in 22nd of April, when 20 people went onto the bridge and jumped simultaneously, we only reached 1/10 of the limit vibrations. So this means that the bridge is really safe, and we even had a safety buffer. So maybe the next bridges could have a slightly stricter design to make a lighter construction material and some costs.
Wow, I feel a lot safer already. Thank you, Maximilian, for taking your time today, and have a nice day.
You're welcome. Thank you very much for the interview, and see you next time.